Hello and welcome to the bonus module on conversion factors and cancellation. This module is meant to be an introduction into unit factors. It should guide you into completing a 1% bonus assignment for Math 117 and should also help you in the second half of your chemistry class and your math class in the GHS program. In the second half of chemistry and math, you'll be required to perform many different conversions. The reason why we practice these conversions is because in the health science field, we often have to do dosage calculations for patients. This is a multi-step conversion, and the process can be intimidating to begin with. We begin by learning how to do one-step conversions using the unit factor method. And once you've mastered this system, you'll be able to apply it for multi-step and more complicated conversions. Our conversion process requires using unit factors. A unit factor is simply a fraction that equals 1. The key aspect of it, though, is that we have different units represented in the numerator and denominator of this fraction. To illustrate this, let's look at some examples. We may know that 1 centimeter is equal to 10 millimeters. Using this information, we can set up two different unit factors. We can write the unit factor 1 centimeter over 10 millimeters or 10 millimeters over 1 centimeter. How we choose to set up our unit factor in our application questions will depend on what unit we're starting with and what unit we're converting into. The unit factors for converting between hours and minutes uses the fact that 1 hour is equal to 60 minutes. This gives us two unit factors, 1 hour over 60 minutes and 60 minutes over 1 hour. The unit factors for converting between kilometers and meters use the fact that 1 kilometer is equal to 1,000 meters. Using this information, we can write the unit factor 1 kilometer over 1,000 meters or 1,000 meters over 1 kilometer. In all of these examples, the numerator quantity is equal to the denominator quantity, but expressed in different units. To do a conversion using unit factors, we always begin by writing down the measurement we're starting from, including the units. Next to this, we'll write our unit factor set up to cancel out units. In order for units to cancel, they must be in opposite positions in the fraction. Generally, the unit we're converting into will be on the top. So to convert between 245,000 meters to an equivalent measurement in kilometers, we use the equality between units we previously discussed. 1,000 meters is equal to 1 kilometer. We begin by writing out our original measurement. Next to this, we'll write down the appropriate unit factor. In this case, we will put the information pertaining to meters in the denominator and the information pertaining to kilometers in the numerator. We do this so that the meters units cancel out and the unit we're converting into, kilometers, remains. Looking at the expression we've created, we have 245,000 multiplied by 1 over 1,000. This is the same as 245,000 divided by 1,000. The result is 245 kilometers. Our unit that didn't cancel is carried over into our answer. Let's look at a few more examples. Suppose we wanted to convert a measurement of 3.45 moles of carbon into grams. In order to do this, we can use our unit conversion method, but we need to know an equality between moles of carbons and grams. You can find this information on a periodic table. The molar mass for carbon is 12.01 grams. This means that 1 mole of carbon weighs 12.01 grams. Now, to convert between 3.45 moles of carbon and grams, we write our original measurement down and our unit factor set up so that the units we begin with, in this case moles of carbon, will cancel, and the units we're converting into, in this case grams, will remain. Now that we've got this set up, we can see what we should enter into our calculator is 3.45 times 12.01. When we do that calculation, we get an answer of 41.4345 grams. When we report it, we should round to the same number of significant digits in our original answer, assuming that the original measurement or original value was a measurement. So our final answer would be 41.4 grams. If we want to convert between 502 grams to an equivalent weight in kilograms, we need to know the equality between grams and kilograms. 1 kilogram is equal to 1,000 grams. Now, we can set up a unit factor calculation to do our conversion. To begin, we write down our starting measurement, 502 grams. Next to that, we're going to put our unit factor. We take information from our equality between the units we begin with and the units we're converting into and set it up so that the units cancel. Now we can see, to do our conversion, we take the 502 value and multiply by 1 over 1,000. This gives us the answer of 0.502 kilograms. Therefore, 502 grams is equal to 0.502 kilograms. Suppose I wanted to convert between minutes and seconds. Again, the first thing I need to know to get started is how many minutes there are in a second or how many seconds there are in a minute. 1 minute is equal to 60 seconds. Using this information, we can set up a conversion factor and convert between 56 minutes into seconds. So that my units cancel, I'm going to put the information about minutes in the denominator of my unit factor and the information about seconds in the numerator. I will cancel out the minute units so that I see the units that I'll be left with. Now to do the calculation, I do 56 multiplied by 60. This gives me an answer of 3,360 seconds. Therefore, 56 minutes is equal to 3,360 minutes, or seconds rather. Hopefully you're starting to see how we can use one conversion factor to convert into another unit. What becomes even more interesting is when we want to link these unit factors together, and this is really where the power starts to be. So suppose we have a 1 carat diamond and we want to know how many moles of carbon are in it. We might not have a conversion factor that lets us go directly from carats to moles. However, we might have 2 unit factors we can link together. We write down our starting measurement. We have a 1 carat diamond. Suppose I know that 1 carat is approximately 200 grams of diamond. Now, next to that, we can link our molar mass for carbon. Diamonds are made out of carbon. We set up our unit factor so that the units will cancel. Since our first unit factor had grams in the numerator, our second unit factor needs to have grams in the denominator. Now that we have our unit factors set up and our units canceling, we can go to our calculator to get the answer. 1 times 200 divided by 12.01 lets us know that a 1 carat diamond is approximately 16.7 moles of carbon, or contains approximately 16.7 moles of carbon. If we want to know how many molecules of carbon there are in that same 1 carat diamond, well, we would have to know how many molecules there are in a mole. That's what Avogadro's number gives us. 1 mole is 6.022 times 10 to the 23 molecules. So, if I have 16.7 moles of carbon in my diamond, then to find out how many molecules that is, I can set up a conversion factor. It's important when we're setting up our conversion factor that we write in the units and see how they cancel to ensure that we're doing the correct operation, multiplication or division. If the value that's not 1 is in the numerator, as in this case, we're going to multiply by the value. If the number that's not 1 is in the denominator, we'll divide by it. In this case, we do 16.7 times 6.022 times 10 to the 23 to get our answer of 1.01 times 10 to the 25 molecules. I hope you found this introduction to unit cancellation useful and can use it to complete your rest of your bonus assignment on unit cancellation. Have a great reading break.